Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT-JEE main and advanced videos.
Hello students, today we'll discuss about the JEE Mains Physics paper 2015. In today's video, we'll discuss about the question number 15. So let us see what is the question. Friends, let us start the question number 15 of 2015 JEE Mains Physics paper. This is the question. It says that a uniformly charged solid sphere. The solid sphere uniformly charged. Uniformly charged means this is a non-conducting solid sphere. In case of a non-conducting solid sphere, the charges will be not only reside over the surfaces, it will reside inside it. So you'll find charges inside it, and that charges are given in the questions uniformly distributed. So you will find uniform distribution inside the solid sphere whose radiuses are and has a potential of V naught measured with respect to infinity. So the potential on the surface of solid sphere, the electrostatic potential on the surface is V naught, that is with respect to infinity, which is always the case. Because when you say potential at a point, it is potential at a point with respect to infinity. That is what we have studied. For this sphere, the equipotential surfaces with potentials for this sphere, the equipotential surfaces with potentials 3V naught by 2, that means it is more than the potential on the surface, 1.5 times V naught, and we know that 1.5 V naught is always present at the center of the non-conducting sphere. 5 V naught by 4, this is also greater than V naught, then it has to be inside. So these 2 points are interior points, and we have a equipotential surface where the potential is 3 V naught by 4, V naught by 4 have radius, these are respectively. So that means when the potential is 3 V naught by 4, the radius of that equipotential surface, obviously that will be spherical, and that comes out to be R1. Similarly, for this potential surface, this is R2 radius, and that sphere has radius R3, R4 and so on. We have nothing to find much, then you have to find which of these relations are correct. That means you have to find R1, R2, R3, R4 and see which of these relations are correct. Okay, so let us first understand one basic important point, that is, if this is solid non-conducting SNC type of charge conducting sphere, you will find charges everywhere inside, uniformly distributed along with the outer surface. This is the center. If I move away from the center, from here to here, the frequency actually decreases from center towards the outer side, but from surface towards the center, the potential will increase. Now, for interior point, the potential is given by, the interior potential, inside potential is given by the expression Q upon 4 pi epsilon naught R 3 by 2 minus R square divided by 2R square. This is the formula of potential inside the surface for any point inside the surface. So I have a situation that I want the potential 3V naught by 4. We have the questions of getting this potential 5V naught by 4, 3v naught by 4 and v naught by 4. On the surface, the potential is v naught. Inside the surface at the center, the potential at the center is obviously 3 by 2 v naught, that we have known. Let us see the other case. So for any point at the center, this point, potential at the center is 3 by 2 v naught, that is 1.5 times the potential on the surface. That can be obtained by using that formula, because we know that q upon 4 pi epsilon r, that formula I will use 3 by 2 minus 2r square by r square by 2r square. If I use this formula, then in this formula r is what? R is the, this is 1, r is the point, the distance of that point where you want to find the potential from the center. So if that point itself is the center, then r is 0. So for this, I put r equals to 0 in this expression. I'll get Vc equals to q upon, which is 3 by 2 kq by r. You can write k for 1 upon 4 pi epsilon naught kq by r. And this kq by r is the v naught. So therefore I am getting Vc comes out to be 3 by 2 v naught. So for that, the r is 0. That means the radius of the sphere comes out to be, if that is given as r1, then r1 has to be 0. So first thing, r1 has to be 0. This one is also r1 0, this one is also r1 0. So then we have to check further where we'll get other points. If I look for the other point, what are those points? 3v naught by 4, 5v naught by 4. This is another point. So this potential can be obtained obviously inside, because this number is greater than 1. If v naught is greater than v naught, this is v naught. If I move away from here, it will be less than v naught. Any point here less than v naught. Any point here greater than v naught. So I want this, so that point must be inside the point. Suppose this is the point. So this sphere that I have drawn, supposing that this is potential 5v naught by 4, so this potential, this surface has radius r2. In the question it is given as r2. Then what is that r2? I have to find. To find r2, I'll use this, then again the same equation, that because for interior points I have the formula v inside equals to 4 pi epsilon naught r kq by r 3 by 2 r square divided by 2r square. If I use this formula, then I have this inside potential is known to me, that is 5v naught by 4. This potential is known to me, then I can put the value of that potential and get the corresponding value of r, that is my r2. So this r2 can be obtained by putting r here as r2. Then I'll get, this is, I'll write kq by r again, kq by r, which is v naught, and this kq by r v naught, and this will cancel out, and this will be 3 by 2 minus r2 the square divided by 2r square. Then from here I can take 2 out and cut this, and I have to get 5 by 2. I'll get 5 by 2 because 2 I cancel out from both sides. This becomes 3 minus r2 square by r square. If I solve this, then this 3 comes to this side, or this one is taken to other side. This will take to this side, and rearranging this r2 square by r square. This is 1 by 2. If this is 1 by 2, then I will have R2 square is R square by 2. From here, I will have R2 equals to R by root 2. Now, I have got this R2. I got this R2. This R2 comes out to be, this R2 I'll write here, that R2 comes out to be R divided by root 2, which is, if I substitute, then it is 0.707 R. Okay, then this is R2, but next potential in the question is next equipotential surface is 3V0 by 4. So if I think of 3V0 by 4, that value is less than V0, because 3V0 by 4, this number is less than V0. If that number is less than V0, then that point will lie outside the solid sphere somewhere here. If this is the case, then I will draw any equipotential surface at a distance. It has given the equipotential surface has radius R3. If the radius is R3, then I assume that with this radius R3, I have the potential 3V0 by 4. So for any outside point, I will just use the formula. I will consider the solid sphere as a point mass concentrated at the center, the point charge. The whole of the charge is supposed to be, the Q amount of charge is supposed to be present at the center of the solid sphere. So for any outside point, I will consider the solid sphere to be a point charge and then find the value of R3, where I have to get the potential of 3V0 by 4. So that means the whole charge is concentrated here. This radius is R3. This sphere has nothing to do because this charge is here. This is the radius. Here I am getting a potential 3V0 by 4. And then if I use this formula, then KQ by R3 is the potential for a point charge at a distance R3. This is the potential, and it's given that this potential is 3V0 by 4. Okay, then if I want to get rid of V0 and want to find R3, because V0 is nothing but 3 by 4, V0 is a KQ by R. V0 is KQ by R, because V0 is this potential on the surface, which is KQ by R. So KQ will cancel out and the R is there, and if I use these two equations, then I have R3 becomes 4R by 3. R3 becomes 4R by 3. So from here I have this relation that R3 is this. Similarly, I have got another point which is given as V0 by 4. Then for V0 by 4 I will choose, I have another potential surface that is V0 by 4, which is also less than V0. That implies for that point also I'll choose a point charge Q here at a distance say R4, because that is given in the question is R4. Then here the potential is V0 by 4. If that is V0 by 4, then I will write the formula that potential V0 by 4 can be written as KQ q by r, that is r4. V naught is kq by r, 4 is there, this cancel out, so r4 is 4r. Now I'll write all those data I have got here. R4 is this, R3 I have got 4r by 3, okay, and what I got last time, R2 also I got, how much I got, 0.707r, and I have got R1 which comes out to be 0. So if we have all these 4 relations, then from these 4 relations I have my work is almost over, and I have to rearrange or look for the particular solutions to this. R1 is obviously 0, so this is I have to choose which one of the 1 or 3 option is correct. Then I have to see this relation, R2 is greater than R4 minus R3 or R2 is less than R4 minus R3. That means I have to find first R4 minus R3 and see if that number is less or greater than R2. So what is the question? The question is I have to find R4 minus R3. Okay, this is what is given in the question. So R4 minus R3, from here this minus this 4R minus 4r by 3, which is 12 minus 4 is 8r by 3. This is the value of r4 minus r3, which is 8r by 3. Okay, so this is nothing but 8r by 3. And what is r2? R2 is 0.7 almost r. If I solve this, this is obviously greater than that, and that comes out to be 3 to the 6, 7, 8, 2, 20, 3, 6, 18, 20. So approximately it is 2.6666. So I write that 2.6 r. So you can see that R4 minus R3 is 2.6 times r, and R2 is 0.7 r. Which one is greater? So obviously R4 minus R3 is greater than this, or R2 is less than R4 minus R3. So that means R2 less than R4 minus R3. This is correct. Again, if I see this option, if I see this option, fourth one, 2R is less than R4, then I will see what is R4. R4 is 4R, and so that 4R is obviously less than, that 4R is obviously less than any number greater than 5, greater than 4, that is 5R, 6R, something like that. But in the question we have given that it is 2R, whether 2R is less than R4, that means whether R4 is greater than 2R. We'll see here that R4 is greater than 2R, obviously, because R4 is 4R, 4R is greater than 2R. This option is also correct. The 4R is greater than 2R, or 2R is less than 4R. 2R is less than 4R means 2R is less than R4. So 2R is less than R4, this is also correct. So we have relations, this one is correct, this one is correct, and R1 is 0 is also correct. So if I include all those answers, then this is correct and this is correct. So options 3 and 4 both are correct. Okay, thank you.